Analytical chemistry is an experimental study which involves both qualitative and quantitative analysis. As the name itself indicates, qualitative speaks about the quality, meaning what is present, and quantitative speaks about the quantity, meaning how much is present. A salt has cation and anion part in it. Generally, a salt is colored if its cation or anion is colored. Group 1 and 2, 13 to 17 ions are generally colorless. Elements belonging to these groups are called as normal elements. If we look in the periodic table, ions of the elements belonging to group 1 and 2, ions of the elements belonging to group 13 to 17 generally remain colorless. Along with these, group 12 ions, that is zinc 2 plus, cadmium 2 plus and mercury 2 plus ions also remain colorless in most of its compounds. If we consider the ions which are made up of more than one atoms from these groups, they also remain colorless. Generally, ions of transition elements are colored. Chromium 3 plus is green, manganese 2 plus is light pink, ferrous, that is Fe2 plus ions are green in color, Fe3 plus ions are either yellow or brown, cobalt 2 plus ions are either blue or pink, nickel 2 plus ions are green, copper 2 plus ions are either blue or green in color. If we consider the ion made up of many elements, example is paramanganate ion, MnO4 minus. In this we are having a transition element manganese. This ion is pink or purple in color. If we consider dichromate ion, that is Cr2O72 minus, we are having transition element chromium in it. Dichromate ion is orange in color. It is important to memorize the solubility of salts in water, specifically at room temperature. We will be listing all soluble salts in water on this side and all insoluble salts in water on the right hand side. All sodium, potassium and ammonium salts are soluble in water at room temperature. All nitrates and nitrite salts are soluble in water. All bicarbonate salts are soluble in water except potassium and sodium bicarbonate. All sulfate salts are soluble in water except lead, silver, calcium and barium sulfate. All chloride salts are soluble in water except lead, silver and mercurous chloride. Lead chloride is insoluble in water at room temperature but is soluble at higher temperature, meaning it becomes soluble in hot water. All sulfite salts are insoluble in water except sodium, potassium and ammonium sulfites. All sulfites are insoluble in water except sodium, potassium and ammonium sulfites. All carbonates are insoluble in water except sodium, potassium and ammonium carbonates. All oxides are insoluble in water except sodium, potassium and ammonium oxides. All hydroxides are insoluble in water except sodium, potassium and ammonium hydroxides. All phosphates are insoluble in water except sodium, potassium and ammonium phosphates. When we use sodium hydroxide as a reagent, we should keep in mind that it is a strong base. In water, sodium hydroxide undergoes complete dissociation to form Na plus and OH minus ions. In short, sodium hydroxide means more number of hydroxyl ions. When sodium hydroxide is treated with a salt, it gives us two different salts. One of them will be soluble in water and another one will be insoluble in water and comes out as precipitate. Let us consider reaction of sodium hydroxide with few salts. Calcium nitrate is a colorless salt or white colored salt. Magnesium chloride is also a white salt. Ferrous sulfate is a green colored salt. Ferric chloride is a brown colored salt. Copper sulfate is a blue colored salt. Zinc sulfate is white colored salt. Lead nitrate is white colored salt. When these salts are treated with required number of sodium hydroxide, it gives us two salts. One salt is soluble in water, whose physical state is mentioned as aqueous inside the bracket. Calcium nitrate gives us white colored calcium hydroxide precipitate. Magnesium chloride gives us dull white color magnesium hydroxide precipitate. Ferrous sulfate gives us dirty green color ferrous hydroxide precipitate. Ferric chloride gives us reddish brown color ferric hydroxide precipitate. Copper sulfate gives us pale blue color copper hydroxide precipitate. Zinc sulfate gives us gelatinous white color precipitate of zinc hydroxide. Lead nitrate gives us chalky white precipitate of lead hydroxide. With the excess of sodium hydroxide, calcium hydroxide, magnesium hydroxide, ferrous hydroxide, ferric hydroxide, and copper hydroxide remain insoluble, whereas zinc hydroxide and lead hydroxide are soluble in excess of sodium hydroxide. When gelatinous white precipitate of zinc hydroxide is treated with excess of sodium hydroxide, it forms sodium zincate. This is a water-soluble salt and forms a colorless solution. In the same manner, when lead hydroxide precipitate is treated with excess of sodium hydroxide, it forms soluble sodium plumbite. We know that active metals react with concentrated acid and release hydrogen gas. Zinc, lead, aluminium and tin belong to a special category of metals which can react with both acids and bases, releasing hydrogen gas. Since tin is not there in ICSE syllabus, we will be considering the reaction of just zinc, lead and aluminium. Zinc upon reaction with sodium hydroxide forms sodium zincate and release hydrogen gas. Similarly, lead forms sodium plumbite and aluminium forms sodium aluminate. Oxidation state of zinc in sodium zincate is +2. Lead is +2 in sodium plumbite. Aluminium is +3 in sodium aluminate. Oxide and hydroxide of zinc, lead and aluminium are amphoteric in nature, meaning they are capable of reacting with both acids and bases, giving salt and water. Here, we are considering the reaction of these oxides and hydroxide only with bases. Zinc oxide and zinc hydroxide react with sodium hydroxide, forming sodium zincate salt and water. Similarly, lead oxide and lead hydroxide form sodium plumbite and water. Aluminium oxide and aluminium hydroxide form sodium aluminate and water. Ammonium hydroxide is a weak base which undergoes partial dissociation in water, forming ammonium ions and hydroxyl ions. In short, ammonium hydroxide means less hydroxyl ion concentration in solution. When ammonium hydroxide is treated with salt, it gives us two salts. One of them is soluble in water, another one is insoluble and forms precipitate. Even over here, we are considering the same set of salts which we have considered with sodium hydroxide. These salts are treated with required amount of ammonium hydroxide. When calcium nitrate is treated with ammonium hydroxide, we will not be seeing any precipitate formation because concentration of hydroxyl in the solution is insufficient to cause the precipitation of calcium ions from solution. Rest of the salts give precipitate. Magnesium chloride gives us dull white magnesium hydroxide precipitate. Ferrous sulfate gives us dirty green ferrous hydroxide precipitate. Ferric chloride gives us reddish brown ferric hydroxide precipitate. Copper sulfate gives us pale blue copper hydroxide precipitate. Zinc sulfate gives us gelatinous white precipitate of zinc hydroxide. Lead nitrate gives us chalky white precipitate of lead hydroxide. With excess of ammonium hydroxide, magnesium hydroxide, ferrous hydroxide, ferric hydroxide, and lead hydroxide remain insoluble. Copper hydroxide and zinc hydroxide, they are soluble with excess of ammonium hydroxide. Let us see what exactly happens with excess of ammonium hydroxide in the next slide. Gelatinous white precipitate of zinc hydroxide upon treatment with excess of ammonium hydroxide forms a coordination compound tetramine zinc hydroxide, and this is soluble in water. It forms a colorless solution. In the same manner, when copper hydroxide is treated with excess ammonium hydroxide, it forms a deep blue color solution of coordination complex tetramine copper hydroxide. Zinc hydroxide is soluble in excess sodium hydroxide as well as excess ammonium hydroxide. Lead hydroxide is soluble in excess sodium hydroxide but insoluble in excess ammonium hydroxide. Copper hydroxide is insoluble in excess sodium hydroxide but soluble in ammonium hydroxide. By using ammonium hydroxide, it is possible for us to distinguish between zinc hydroxide and lead hydroxide. Both are white in color.